Here we established the definition of any order forward difference. Here particularly we define the kth order forward difference of f of x in terms of the summation of the function of x. And this problem from your previous year university paper. Okay, and the problem is of type prove that delta to the power k f of x, this is equal to summation I equal to 0 to k minus 1 to the power I k c I f of x plus k minus I into h, where h is the step length, or it may be in the form for any positive integer k, right? This is not n, k, so that delta to the power k y0, this is summation I equal to 0 to k minus 1 to the power I k c I y k minus I. Clearly it is given that if we put y0, this is equal to f of x, then y k minus I, this is obviously equal to f of x plus k minus I into h. Okay, that is this expression and this expression are same. Now to prove this expression, we first write the definition of forward difference of first order, and the definition is delta f of x, this is equal to f of x plus h minus f of x. Okay, and we write the right side as by summation notation. This is I equal to 0 to 1, and this is minus 1 to the power I, and this is 1 ci into f of x plus 1 minus I into h. Okay, when we put I equal to 0, then this is plus, and 1 c 0, this is 1, and this is x plus 1 into h, this is f of x plus h. So the first term come from putting I equal to 0 and putting I equal to 1, we get the second term. Okay, now similarly if we write the definition of delta square f of x, and this is delta of delta f of x, this is delta of f of x plus h minus f of x. So this is delta f of x plus h minus delta f of x, and clearly this is f of x plus 2h minus this is f of x plus h, and from here the first term is also minus f of x plus h, so we write this is 2 into plus f of x. And in similar manner, we write this result in summation form as I equal to 0 to 2 minus 1 to the power I 2 ci f of x plus 2 minus I into h. Okay, so we say that this given relation is true for k, this is equal to 1 and 2. Okay, now we let it is true for k equal to m. Okay, that is we let here delta to the power m f of x, this is given by summation I equal to 0 to m minus 1 to the power I mci into f of x plus k minus I into h. Okay, now to write the result of delta to the power m plus 1 f of x, this is given by delta to the power m f of x plus h minus delta to the power m f of x. We already write the value of delta to the power m f of x here. Okay, and there is not k, this is m, because here we take m in place of k. Now we write delta to the power m f of x plus h. Then we put x plus h in place of x here. So we get this is summation I equal to 0 to m minus 1 to the power I mci. This is f of x plus h. This is h plus m minus I into h. Okay, so we write this is summation I equal to 0 to m minus 1 to the power I mci f of x plus m minus I plus 1 into h. We taking common h from this total. Okay, now to change the variable of the summation, that is to change I, we put here I, this is equal to L plus 1. Then this summation becomes, this is summation L, this is equal to minus 1, because if I equal to 0, then L plus 1 equal to 0, that is L equal to minus 1, to m minus 1. Why m minus 1? If I, this is equal to m, then L obviously this is equal to m minus 1. Okay, so we put here L equal to minus 1 to m minus 1. Otherwise, all the term we put here L plus 1. This is m c L plus 1, and this is also f of x plus m minus, this is we put I equal to L plus 1, so 1 cancel out, so this is m minus L into h, right? This is the summation. Now we write this summation in two terms. We separate the first term from the summation and putting L equal to minus 1 here, we get minus 1 to the power 0 mc0. This is f of x plus mh, because L equal to minus 1, sorry, this is not mh, this is m plus 1 into h. Okay, and the remaining term in the summation, that is L, this is equal to 0 to m minus 1 minus 1 to the power L plus 1 m c L plus 1 into f of x plus, this is m minus L into h. Okay, now putting the value of delta to the power m f of x plus h and delta to the power m fx is the definition of delta to the power m plus 1 fx, because the definition of delta to the power m plus 1 fx is delta to the power m into fx plus h minus delta to the power m into fx. Okay, so we put two values. The first value is, this is minus 1 to the power 0, this means 1, and this is mc0, and f of x plus m plus 1 into h, this is the first term, and we write here a minus and here L equal to 0 to m minus 1, and we change, this is minus 1 to the power L, because minus 1 to the power 1 we write outside, so this is minus. Okay, and the remaining term is mc L plus 1 into f of x plus m minus L into h. Okay, this is the same, and now we write delta to the power m fx. We write this term, but we put here L equal to I. Okay, changing I to L, because I is a variable of summation, so we get, this is plus, this is summation I equal to 0 to m, this is minus 1 to the power I m c I, this is not I, this is L we put here, this is also L, this is also L, and this is f of x plus m minus L into h, right? Now for the last summation, we take the first m minus 1 term in this summation and write the last term in separate form, and this relation gives, the first term is mc0 f of x plus m plus 1 into h minus taking common L, this is equal to 0 to m minus 1 minus 1 to the power L in the both case, and this is mcl plus 1 minus mcl, right, and this is f of x plus m minus l into h. This can be taken as a common from the both term, and another term here remains because we take l equal to 0 to m minus 1. So the last term is, this is minus 1 to the power m, because this is minus 1 to the power m, and l is equal to m here. This is mcm, and this is f of x plus, this is m minus m, this is 0, so this is f of x. We write delta to the power m plus 1 f of x. Here we write first the first term. This is given by mc0, and mc0 means 1, and we can also write this is m plus 1c0, because mc0 and m plus 1c0 get the same value. This is 1. Okay, so we write this is m plus 1c0, right, and the function is f of x plus m plus 1 into h. This is the first term, and here we make a small mistake. Since in the definition there will be a minus, so it must be minus sign. Okay, and now we take minus sign from this and this, then we get this is plus. Okay, otherwise all right, and we use the formula. This is mcr plus mcr plus 1. This is given by m plus 1c r plus 1. Okay, and we write this formula here, and this is given by minus, this is summation L, this is equal to 0 to m minus 1, this is minus 1 to the power L, and this is m plus 1 c L plus 1 into the function is f of x plus m minus L into h. Okay, and if we write this is minus 1 to the power L, not L, this is L plus 1, then we get extra minus, so this is plus. Okay, to get similarity, here L plus 1 and here L plus 1, so we get this is plus and this is L plus 1, minus 1 to the power L plus 1, and the last term is minus 1 to the power m into, we can write this term is m plus 1c m plus 1, because m plus mcm, this is equal to 1, and m plus 1c m plus 1, this is also equal to 1. And here is also a mistake, because this minus, and here is also a minus, because in the definition this is negative term. Okay, so we get here minus and here another minus, and this is minus. Now making this is plus by taking here minus 1 to the power m plus 1. Okay, and the function is f of x, and we write this is given by m x plus, we write in the form of m minus l, and this is m plus 1 minus m plus 1 into l here. Okay, so this is remains f of x, because m plus 1 minus m plus 1 into l, this term is 0. Sorry, this is not l, this is we write into h. Okay, to get similarity of this term. And in the summation form, we can write this as summation L, this is equal to 0 to m plus 1, and this is m plus 1 CL. And we first write this is minus 1 to the power L plus 1, and this is not L, this is L plus 1. Now to get this summation in the form of I, we put here L plus 1, this is equal to I again. Okay, that is we put L, this is equal to I minus 1. And here the summation is L equal to 0 to M minus 1. So I, this is equal to 1 to, this is M minus 1 plus 1, that is equal to M. And this term becomes delta to the power M plus 1 f of x. This is equal to, the first term is same, M plus 1 c 0 into f of x plus M plus 1 into h plus summation. This is I equal to 1 to M, because L equal to 0 to M minus 1, we already says here, and this is minus 1 to the power I, because L plus 1, and this is M plus 1 Ci, this is L plus 1, and this is f of x plus M minus, this is L equal to I minus 1. So I plus 1 into h. This is this term becomes this. And the last term is minus 1 to the power M plus 1. This is similar as the previous line. M plus 1 into f of x plus M plus 1 minus M plus 1 into h. Okay, and clearly these three terms, this term, this summation and this term can be written in a single summation as summation I equal to 0 to M plus 1 minus 1 to the power I, because minus 1 to the power 0, this is 1, and minus 1 to the power M plus 1 is present here, and other term in the summation, and the middle term is f of, we write this term M plus 1 Ci into f of x plus M minus I plus 1, or we write this term as M plus 1 minus I into h. Okay, and this is the formula of M plus 1 f of x we get. And clearly if we look carefully, delta to the power M plus 1 fx and delta to the power M fx, we say that the given relation is hold for k equal to M plus 1 if it is hold for k equal to L. Okay, so by principle of mathematical induction, we say that this relation or the given relation is hold for all k belongs to capital N, that is natural number. Okay, and so we prove the important result, delta to the power k into f of x, this is equal to this term. Thank you for watching.